So hello friends, welcome to online lecture series. This is the second lecture of your unit number 2 in physical chemistry. It means paper number 503. Okay. So in our previous lecture we discussed about three main basic definition. First one is phase, second one is components, and last one is chemical constituents. Okay. So today I will discuss one more basic term, that is degree of freedom. And it is denoted by capital F. Okay. So first, what is the meaning of degree of freedom? The degree of freedom may be defined as the minimum number of variables which must be specified to describe all the phase of the system. Okay. So first of all, what is the meaning of degree of freedom? Degree of freedom means how many minimum number of variables are required. Degree of freedom means how many minimum number of are required to describe all the phase of the system. It means thermodynamics variables like pressure, temperature, volume, concentration, mole, okay, etc. So how many minimum numbers of thermodynamics variables are required for specified the all phase of the system? Okay, suppose in closed container we take liquid and gas. In closed container we take liquid and gaseous particle. Okay, this is the liquid and this one is the gas. Okay, suppose if I know the value pressure and volume for this condition. Okay, suppose pressure and volume are known, at that time temperature is unknown, so we can easily calculate temperature by using ideal gas equation, that is PV is equal to nRT. Okay, so by putting the value of pressure and volume we get the another term, that is temperature. Okay, so it means here the number of minimum variables are 2. If third one is unknown, then it is easily calculated by thermodynamic equations. Okay, so the degree of freedom means how many minimum numbers of variables are required to define all the phases. Okay, so if it is denoted by capital F. Suppose capital F is equal to 0. Capital F is equal to 0 it means no any one variables are required for this system. F is equal to 0, it means no any variables are required to define your system. It means it will become non-variant. Suppose the value of F is equal to 1, it means it is a monovariant. F is equal to 2, it means it is a bivariant. F is equal to 3, it means it is a trivariant. Okay, so what is the basic? It is the basic definition. Degree of freedom means how many thermodynamic variables are required to describe your all phase of the system. It is called a degree of freedom. Here the value of F 0 non-variant, if F is equal to 1 monovariant, F is equal to 2 bivariant, F is equal to 3 trivariant. Okay, and second one is Gibbs phase rule. So Gibbs phase rule states the relation between components phase and the relationship between component phase and degree of freedom. Okay, so Gibbs give a mathematical expression for relationship between degree of freedom, components and phase, and it is known as Gibbs phase rule. Gibbs phase rule states the relationship between degree of freedom, components and phases. Okay, and the mathematical expression of Gibbs phase rule is F is equal to C minus P plus 2. Here F indicates degree of freedom. Degree of freedom means how many minimum numbers of variables are required for define this system. C means components, P means phases plus 2. Okay, suppose if I have 3 component system, that is petrol plus kerosene plus oil. Petrol plus kerosene plus oil is a 3 component system. Here 3 components are given. First one is petrol, second one is kerosene, and the last one is oil. And all are they mixed with together. It means it form a homogeneous system. So the value of phase P is equal to 1 and the component is equal to 3. Okay, so I put the value of C is equal to 3 P is equal to 1 plus 2. That means it means 3 minus components is equal to 3. 3 minus 1 plus 2. It means 5 minus 1. It is equal to 4. It means it is the maximum degree of freedom. It is the maximum degree of freedom when phase is equal to 1, when the value of phase equal to 1 and components is equal to 3. It is the maximum F. F means degree of freedom. Okay, so F maximum is equal to 4. Okay, and second one example, sand plus oil plus H2 and liquid, H2 and gas, H2 and solid. It means in closed container, suppose I take plus ice plus vapor of water. It means vapor in gaseous form plus sand and also oil. It means here the value of components are 3. It means all these 3 components are same. H2 and liquid, H2 and gas, and H2 and solid. So the value of components is equal to sand plus oil plus water. It means 3 components minus P. P means phases. Here we can see that sand plus oil plus water in liquid form, water in gaseous form, and water in solid form. These are not form a homogeneous mixture. So it is a immiscible liquids, immiscible type examples. Okay. So the value of P means phases. How many phases are occurring in this case? So first, all of the components are different. It means sand is not dissolved in oil, plus water in liquid, water in gas, water in solid. So the value of phases P is equal to 5. Okay. See, component is equal to 3, sand plus oil plus this water, and minus P means phases are 5, different 5 phases are given, and plus 2. It means 3 minus 5 plus 2 is equal to 0. 3 minus 5 plus 2 is equal to 0. So here we can see that for define this system we don't have need any variable, because this is a not miscible liquids. This is all the molecules are not mixed together. It means here the value of F is equal to 0. It means here it is a non-variance system. Non-variance means no any variables are required to define these all phases, because this is a not homogeneous mixture. Okay, and here we can see that 5 phases are in equilibrium in a system. First one is H2 and liquid, H2 and gas, H2 and solid, sand plus oil. So at that point 5 phases are in equilibrium in a system with 3 components. Here we can see the 3 components are given, sand plus oil plus water, with 3 components, and it becomes non-variant, and the point at the 5 phases are in stable equilibrium, it is called quintuple points. Okay, so what do you mean by quintuple points? All the 5 phases are equilibrium with 3 components. With 3 components is called quintuple points. Okay, so for in quintuple points the value of F is equal to 0. The value of F is equal to 0. It means the system becomes non-variant. So what do you mean by quintuple point? At that point all the 5 phases are in equilibrium with 3 components, and the system becomes non-variant, is called quintuple points. Okay, so in this lecture I will discuss about only one term, that is degree of freedom. It means the degree of freedom means how many minimum numbers of thermodynamic variables are required to define this system. Okay, so suppose F is equal to 0, it means system becomes non-variant. F is equal to 1, monovariant. F is equal to 2, bivariant, and F is equal to 3, trivariant. Okay, and give a relationship between phase, component, and degree of freedom. It is known as Gibbs phase rule. Okay, so this is the mathematical expression of Gibbs phase rule. Here for 3 component system like petrol plus kerosene plus oil, so components are 3, phases is equal to 1, because these 3 forms homogeneous mixture. Okay, so the phases is equal to 1, and the value of degree of freedom we get the F is equal to 4. Okay, in our second example, sand plus oil plus water in liquid form, water in gaseous form plus water in solid form. So in this case, no any molecules are mixed with together. It means it form 5 different phases with 3 components, and the value of F is equal to 0. It means this is a non-variant system, and at that point this all the 5 phases are in equilibrium with 3 components, and the system becomes non-variant. It is called quintuple points. Okay, so in this lecture I will discuss only one term, what is the degree of freedom and what is the relation of degree of freedom with component and phases. It is also known as Gibbs phase rule. Okay, so in next lecture I will discuss about how to represent component system in graphical. Okay, so thank you for watching this video.